Today I'm going to show you how to make this very simple LED uplight. These are ideal to bring general lighting anywhere you need it. This version puts out a lot more light than a 25-watt light bulb, but only consumes about 3 watts. It is low voltage, so these can be placed anywhere indoors without concern about electrical wiring. Right, let's talk about the parts that we'll need for this build. The key piece obviously is the metal, and I got this at the hardware store. This is 12 inches. I cut this down to 12 inches and it's 3/4 inch wide and 1/8 of an inch thick. There's also 1 inch and maybe 1 1/4 inch I think it comes in, so you can, depending on what kind of look you want to go for, but I found this works pretty well. The next key ingredient is the LED, and this one is a Bridge Lux. I'll put the numbers in the comment section. This one is 8.8 volts at 700 milliamps. When you're running at 12 volts, you want to get an LED that's a few volts less than the voltage you'll be running at, because you'll need to regulate it somehow, and the regulator needs some voltage, a few volts to work with. The next part is the shoulder washer. I'm going to drill a hole through here for the wire to go through, and this will protect the wire from the edges of the metal in case the wire gets pulled down or anything like that. And then finally we have the wire. And for this I'm going to use zip cord, but this is 22 gauge. But you can also use 22 gauge wire and just single wires and twist them together if you want. And that's pretty much it for this build. The next step, we'll need to lay it out. And this is always a critical step. You can't start drilling and start making things until you have a good plan. So the first step is to figure out where to bend it, where the hole should be, and where the LED should be. So I'm going to drill 2 holes for mounting it to the wall, and we'll put this one 1 inch in, and we'll put the other one 1 inch from the bend, and that leaves 3 inches in between. And at 5 inches it'll be bent at a right angle, 90 degrees, and then say 1/2 an inch or 3/4 of an inch, let's say 3/4, to where the hole for the wire is. So let's lay that out, and we'll get a ruler and we'll mark 1 inch for the one mounting hole, and then right here for the other mounting hole, and then a bend here at 5 inches. And then 1 inch from the end we'll put the LED. Don't really need to mark that. It doesn't have to be precise because it's going to face up and nobody's going to see that. So the first thing to do, oh, and also the 3/4 inches for the, we'll say 5 3/4 inches from the end. So 5, we'll make it 1/2. I'm just wondering because of the shoulder washer is nearly 1/2 an inch. So we don't want to get too close to that. So yeah, let's make that 3/4 inch. Okay, we'll make a mark right here at 3/4 inch. And now to get all these centered, I'll use a divider. And this is almost like a compass, but you just set it to something like 3/8 of an inch. And that's 1/2 of the 3/4, and so that can tell you that you have it in the center. And so you can make a mark there like that, right on the edge, and one here for this hole, and then one here for this hole. And that's all we need to do for that. Before we drill this thing, we're going to want to punch with a center punch, because otherwise the drill might start moving around. So center punching the holes is a very good idea if you are not in a rush. So just make a nice little dent with that. This is just a small punch, center punch. Don't have to go too deep, I guess. And then one for the grommet, or the shoulder washer, and that'll keep the drill centered. Alright, to drill this, we'll start out with a small drill. It's always good to start with a small drill for like a pilot hole, and then work up to the larger drill sizes. And with the small drills, I'm just going to hold on to it. It's not going to have much torque, but when you get to the larger drills, you want to hold this down firmly, of course. You can use a hand drill, but a drill press is better if you have it. So let's just drill these the spots that I punched before. Oh, sorry if my hand is in the way. Okay. Got this turned around a little so it'll look better on the camera. The next drill is I'm going to use a 0.2 inch drill, and that's because the drywall screws, that'll be a good size for that. But I'm going to drill all the holes with that just to open up even the larger hole that's going to be drilled with a larger drill for the shoulder washer. And get that moved up so that it's close, so you don't have to crank it down so far. And actually, safety first. It's good to use some sort of a clamp that will hold the work firmly, so you don't, if the drill bites, then it doesn't get away from you. Alright, the next drill is 0.3, let me see, 0.323, which should fit the inner diameter of the shoulder of the shoulder washer. Oh. Get this adjusted down. And since the smaller holes are finished, I'm going to use this drill just to give a little deburr the mounting holes. And then we'll drill the hole for the shoulder washer and see how that fits. All right. Here's the shoulder washer, and that drops in there right nice. That'll be fine. I just take a large drill and deburr this hole, and that's ready for bending now. The next thing we have to do is make a bend on the mark, and you could do this in a vise and just hammer it over, or use a 2x4 and just tweak it over. But this is one of the Harbor Freight a universal bender, what they call it, compact bender. And this is really useful for this, if I can just remember how it goes together. This bending attachment goes here. And then the second hole goes in here. There we go. That goes there, and then the roller goes on the end like this, and then you push that all the way back. And I want to be careful of this hole because it's going to want to bend where that hole is. So I'll put that in the back. And so put it right to where the mark is, right in here, and it's going to bend around this attachment here. These benders are very useful if you're going to do a whole lot of these things, and they're about $100 or less than that, I think. And they also have a short one that you can mount on a bench. But now that we have that in there, now we pull the handle and make sure everything is in the right place. Whoop, that's going to have to go. This thing is for, you can bolt that down to keep your position so you bend everything to the same level. And you just go like that. Good enough. Now comes the messy part. We got to use the epoxy and mix the two equal parts. And these lure locks just seem to not do so well with this stuff, but we'll just get just a tiny bit and try to make it equal. It's not that critical. You don't need much of this stuff, but I just put a nail in there to keep that one. And then try and get some of that off of there because that's more than necessary, more than needed to be equal. Try to get the mixed stuff away from the stuff that you're not going to mix so that it doesn't affect the doesn't get it so that you have a partial mix. You want to make sure that the stuff that you're going to use is going to be completely mixed. And the next thing is very important. You got to clean the surfaces. So use a little alcohol and clean that. And even though these are fresh from the factory, it's good to clean the LEDs as well. And now, just take up some of that. Again, you don't need very much. Just try and get it as coated as much as possible, because this will transfer the heat from the hot LED to the aluminum, and that makes it an excellent heat sink because it's such a big piece of aluminum compared to the LED. Try not to mash this all over my fingers. It's really good if you're going to build several of these to do them all at the same time, because then you only have to do this mess part once. And on this LED, let me get a close-up up here. This LED has 2 positive terminals and 2 negative terminals. So you want to make sure that you orient it so that you have a negative and a positive going back to where the wire is going to be. So we'll just drop that right onto there. One thing about this epoxy is that it wants to cure under heat. And they say on the data sheet 80 degrees centigrade for 1 hour. And so you can use a hot plate. You might want to measure it with a thermometer to make sure that it doesn't get too hot. Or you can let it heat up and unplug it after a while and just watch the temperature. This is a small film heater that I got off of eBay, and it actually goes to about 90 degrees C when you run it at 12 volts at half an amp. And so this is just perfect. I'll just run it at 11.5 volts or something like that. And so this will warm up the LED, and then I could just put a little pressure plate on here, like that, and then plug that into 12 volts. You could also use your home oven, but that's probably not recommended. You don't want to put chemicals in anything that you're going to be eating. It's obviously a negligible amount of chemicals, but it's just good practice to use specific tool type things and keep them away from food. So I'll turn that on to 11.5 volts. And then we'll just let that sit in there and cook for an hour. Now that the glue is set, this is what it looks like. If you get a little extra glue on the sides, it's easy to scrape off with an X-Acto knife. So now it's time to tin two of these terminals here for the wires, and tin the wires. And what I'll use is a hot plate from a junk store. And this one gets up to 160 centigrade after about half an hour. I've got a thermometer here that I'll set just to show you what it looks like. But if you don't have a thermometer, you could probably turn this on for 10 minutes and then unplug it and then use it to solder. That way you know it's not going to get any hotter. It's not ever going to get hot enough to damage the LED because according to the data sheet for this one, the soldering temperature can be 350 degrees centigrade, and this only goes to 160, so this is never going to get hot enough. But there's no need to keep this on so hot that it gets more than necessary. Turn this on for 10 minutes, unplug it, then you can solder, and it's safe, and it's not going to get too hot or unnecessarily hot. All right, this heat plate has been plugged in about 8 minutes now, and it's about 110 degrees. So now what I'm going to do is unplug it, and then that way it can just sit there and do whatever it's going to do. And then we get the unit on here and put some paper insulation on it and some weight, making sure not to let that touch the thermocouple, or it's got an edge here, so it's sticking up actually. And then we just apply some solder. And that's tinned. Now I tinned the wires off camera just to make them short and don't pull the insulation apart too much, and just try to make it fit generally there. I used some of this flux. You want to put some flux on the wire and on the terminals, and then try to solder with the camera in the way. You notice the white stripe is for plus. To make sure it gets heated thoroughly. You want to inspect the connection very carefully and make sure that, I don't know if this is going to focus, make sure it looks smooth and there's no stray wires hanging off or anything like that. The flux can be scraped away with an X-Acto knife. Wait till it cools down, and then just scrape off the flux just to make it a little bit neater. So the next thing will be to put the wire through the hole with the shoulder washer and use some hot melt glue to tack this down so that when you see it up on the ceiling, you don't see the wires sticking out. So we'll get to that next. Okay, I cut this off at 10 feet, and so the next step is to feed this through the shoulder washer and then through the hole. And after that, so that goes through there, and that goes down through there. And the hot plate is still a little warm, which is good with the hot melt glue. And also one thing you want to do here is fold the wire so that it lays flat. So just push it like that, and then that way it'll lay nice. So you don't want it sticking up like this, because you'll see that when it's up on the ceiling. You'll see the wire. So it's important to glue this down somehow. So you just put a dab there. And put a dab here. And just let that set first. If I take it off the hot plate now, it doesn't need to be on there anymore. You can do a neater job. It's a little difficult with the camera in the way. And now it's good to glue this washer down. Let me adjust that. So I just stick a drop on both sides. Now if you don't have a shoulder washer like this, you could just use hot glue around the wire, and that would give some sort of a protection. Because if somebody pulls down on the wire here, it's going to rub against that corner, and you don't want that. And I think I'll put one more dab right here, just to make sure the wire stays down. And that's the main unit complete. Before we go any farther, it's important to test the unit before we get ahead of ourselves. So I've got the variable power supply set to 12 volts, and if you have an adjustable power supply, you can limit it to 700 milliamps so that it won't overdrive the LED. I have an LED testing device here that is very good for putting that over there so that it doesn't blind the camera. And I have a meter here set up on the 10 amp plug there, and this is a 5.11 ohm resistor, and the LED takes 8.8 volts, so you subtract that from 12 volts and that equals 3.2 volts. So that's what's going to be dropped across the resistor. So if we touch this on here, yeah, 0.5 amp. So that's a good test. In future videos, I'm going to talk about much more efficient ways of driving these LEDs and controlling them. But on this one, I just want to run it off to 12 volts. So I'm going to show how to do a simple LM317 current regulator. And then you could just run the LED off the 5 ohm resistor like I showed before. But the problem with that is if the voltage goes different than 12 volts, say 14 or 18 volts, then that means the current is also going to go up and you could burn out the LED. So by using an LM317 regulator, it can have a wider voltage range and it won't be so sensitive to the exact voltage. To build this, you'll need a LM317 linear regulator and a 1.8 or 2 ohm resistor. This is a 7 watt resistor. You really only need 3 watts. I believe it's 2.24 watts that theoretically this will be burning. So you want something more than a 2 watt resistor. And like I said, this is I believe it's a 7 watt resistor at 2 ohms. So this is overkill, much bigger than necessary, but it's just to demonstrate really. So to start, we'll solder the resistor between pins 1 and 2. So basically making this connection right here. As I said, I'm new at this, and it's just soldering on camera is like soldering left-handed. So I just put that underneath there, and clamp that down a little bit. And I'll put a heat shrink over this end of the resistor later. A little tricky to clamp this in. The datasheet recommends a 0.1 capacitor, so just use a small monolithic capacitor. That somehow helps the regulator. And I'm trying to find a way to clamp this in that is convenient. And what we'll do is just bend this pin 3. And then I'll just bend a loop in this to go around it. And then just clamp that to hold it. Now, power and ground input are these 2 pins here, and the LED output is this pin, which is ground, and this pin over here, which is pin 1, which is this pin here. So now we can put some wires on it. Next, we'll get the power wires soldered on. I'm not good at the Clive method, three-fingered soldering. I like to use the clamp. And so first thing is this monolithic capacitor. This is minus and this is the plus input. And two wires are going to go on the minus, the LED and this power wire. And so just smash that in there. And hit that with some solder. And hold it so it doesn't go anywhere. And the same with the red wire. And this will go over here. And no more goes on that, so that's a final connection, this one here. I like to do a better job soldering if I can. It's a lot easier to do this with a microscope, because then you can really get in there and see what you're doing. But for this, I'll keep it simple. So that's the power input, and now we can solder on the LED on the output. And unfortunately, this isn't really good at grabbing this. That'll hold good enough. So now we have the wires from the LED, and this is the plus terminal here. Well, I'm sorry, this is the ground terminal here for the LED. So this is the plus one, and that goes on the other side over here. And what I'm going to do is cut this one a little bit short so that it lays nice. We'll just tin that a little bit. So then we want to put that negative lead without the stripe over here. Just like that. And hit that with some solder so it doesn't go anywhere. And then we can trim this little connection here. And then this wire goes over to pin 1 because the LED connects directly to pin 1. And I'll just bend that to the left. Left-handed soldering, I tell you, something else. And it's good to hook these things so that they have a physical strength, not just touching the solder where you can. Sometimes it's not easy. Come on, there you go. Just grab that and pull. And that's complete. And now what I'll do is I'll use a little bit of heat shrink, a little bit of hot glue, and just put some glue on a few places here just because you don't want this to short. And I'm going to use a piece of heat shrink on here. But for now, for testing, we'll just keep this away because this output, this is the plus output, which is equivalent to, I believe, pin 2. And so you don't want this tab touching anything. So I'll put a sleeve of heat shrink right over this part here. But just inspect it very closely. Make sure everything is looking good and nothing's touching like this. Just got to check your work at every step. And then we'll test. Alright, to test we'll hook up the meter just like it was before. Get this in the shot here. And we'll hook up minus. And plus. And put on the 12 volts. Oh, we need the special photographic shield. Now 473 milliamps, and this is with a 2 ohm resistor. So with a 1.8 or 1.7 resistor, you get much more current. But this light is plenty bright at even half the rated current. So it's up to you to how close to the 700 milliamps. It's always good to not drive them right up to the spec also, because that'll make them last longer and just be easier on them. And here's what the final result looks like mounted on the wall near the ceiling. It's about 13 inches down, mounted 13 inches down from the ceiling, and you can get an idea of what the light spread is. And on the ceiling, so here's 2 feet over here, but of course you can mount it higher or lower as you need. I hope you find this project useful. Completed lamps are available through the website below in the video description. Customized versions may be available as time permits. Contact information is below. Please leave a comment which will help make future videos better.